Guys, we're going to finish up this lesson and do 11.4b on area of composite figures. A composite figure is a figure that can be separated into regions that are basic figures, such as triangles, rectangles, trapezoids, and circles. And so we've done the area of all of those figures. So that's what we're going to do again. It says to find the area of the composite figure, we're going to find the area of each basic figure, then use the area addition postulate, which just means that we're going to add the two areas together. In 4a, it says find the area of each figure and round to the nearest tenth if necessary. So the first thing we want to do in any of these composite figures is break it up into figures that we already know. And I can already see a couple of different ways of breaking up 4a here. One of which is just to draw in this perpendicular line, and then I have our rectangle here, which has opposite sides are 8 and 8 and 12 and 12. And then I also have a trapezoid, and we have specific parts for that as well. So I have two figures. I have the area of a rectangle and I have an area of a trapezoid. And so what I'm going to do is put those together, and then that gives me the area of the composite figure. Composite just means the result of putting two together, two or more. Let's start with the area of the rectangle, and rectangle is base times height. So we want to recognize what those are in the figure. I'm going to let maybe the height be 12, and for the rectangle, the base be 8. And we'll substitute those in. So we get 12 inches times 8 inches is 96 inches squared. So that's just the rectangle. Then we want to come back and we want to do the trapezoid. So for the area of the trapezoid, that's 1/2 the height times base 1 plus base 2. And so for that, I'm going to let 5 be my base 1, 12 is my base 2, and then my height, I'm going to have to do a little math for that. All the way across was 15 inches, but I already have 8 inches, so the height of the trapezoid would have to be 7 if I were to subtract those. So this is my height. That's for my trapezoid. Okay, then we'll plug those in. So I have 1/2. The height is, we decided for 7 inches. The base, or bases are 5 inches and 12 inches. And so I have 1/2 times 7 inches times 17 inches. And then I'll get my calculator out and we'll do a little math. So 0.5 times 7 times 17 is 59.5. Now we have to come back and add those guys together. So the area of the composite, I'll just kind of abbreviate there, is 96 inches squared plus 59.5 inches squared, which is 155.5 inches squared. So that's the area of our composite figure there. I'm not going to completely do B, but I am going to look at what are our different parts here. And I could actually break this up into 3. If I drew in this perpendicular so that I have a half circle, I have a rectangle, and I have a triangle. And so then I have to find some of my missing parts. So for the rectangle, I'm going to start with that one because that one's going to be the easiest. We need to remember the opposite sides are congruent. So this 31 actually belonged to this whole side. So for the rectangle, this would be 22. And this section right here would be 31 minus 22, which would be 9 centimeters. So that's going to give us a value in which we can use Pythagorean theorem then to find the height, not only of the triangle, but also the height of the rectangle. And then, since those are the same thing, that will give us the diameter of the semicircle. Now, just to kind of remind you, area of a triangle is 1/2 base times height. Area of a rectangle is base times height, and area of, this is a half a circle. So we start with a whole circle, which is pi r squared, but then it's a half of one, so we're going to come back and divide by 2. So those are the different formulas that we would use. And then to get our composite, I'm going to add the area of the triangle plus the area of the rectangle plus the area of the half circle, and that would be my composite. Okay, in 5A and 5B, we're still finding the area of the composite figures, but we're going to use subtraction this time. The outer figure here is a shape that we do know, and that is a trapezoid. So I'm going to start with the area of the trapezoid. And then what I'm going to do is I'm going to subtract, because you'll see I have a missing piece. I'm going to subtract this triangle in the middle. And I do see that I'm going to have to do a little bit of work here. The area of my trapezoid is 1/2 the height times base 1 plus base 2. And so I have my base 1. Maybe I'll let this be base 2. I've just got to add the parts together there, so that's 12 meters. But I don't have my height, and I'm going to have to use this little triangle here in the middle to do that. So if we kind of pretend like we enlarge it here, this is 2 meters. And then this is my height, and this is 6 meters. So I've got a skinny little right triangle there that I'm going to use to find my height, which gives me, that's only half of the width of the triangle, so that would be 1, and I'm going to use Pythagorean theorem. A squared plus b squared equals c squared. My base and my height, or my A and my B, is 1, and x, or the h for the height, and the hypotenuse is 6. And so I'm going to subtract 1, and then I have to come back and find the square root. And so x, which is my height, is about it's about 5.9. Okay, so that's what I'm going to use for my height there. Okay, so for the trapezoid, I have 1/2 times the height, which is 5.9 meters. My base 1 was 8 meters, and base 2 was 12 meters. Inside the parentheses, that's going to be 20 meters, and that's going to give me 59 meters squared. So that's my trapezoid. Then I want to find the area of the triangle. Well, I've got my triangle over here. Here's my triangle. And so the area of the triangle is 1/2 base times height. The base is my 2 meters. My height, we figured out, was 5.9 meters. And so that's what I'm going to put in here. So 1/2 2 meters times 5.9 meters is equal to 5.9 meters squared. And I said that for the composite, I want to take the area of the trapezoid minus the area of the triangle for this because we kind of got a hole in it. The trapezoid was 59 meters squared, and the triangle is 5.9 meters squared, which gives me an area of 53.1 meters squared. And that's the area of our composite figure. All right, for the other one, we have, it looks like a parallelogram, and then there is what looks like is a kite that has been taken out of it. So I'm going to do the area of a parallelogram, which is base times height, and the area of the kite, which is 1/2 diagonal 1 times diagonal 2. And so the composite the area of the composite would be the area of the parallelogram minus the area of the kite. Now remember, in a parallelogram, opposite sides are congruent. So this is going to be 14. And so this right here, which is still a length, is also 14. So that's one of your diagonals. And then we'll need to find the other diagonal. I guess the other diagonal would be 9 then, because it's the same as the height. So you've got your base and your height of your parallelogram, and you've got the diagonals of your kite there. Okay, there's going to be an assignment attached to this, and we'll be done with lesson 4. Bye.